Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Let's start. Let's get into the start. So we can go with the. Myopia, 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 myopia. Near distance we can see ya. Far distance we can't see ya. Myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Myopia, 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 myopia. Near distance we can see ya, far distance we can see ya. Myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction we are using convex lens, convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia. For the correction we are using convex lens, convex lens. New Cartesian, new Cartesian sign convention, new Cartesian sign convention. All distance are measured from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Are negative below the principal axis. Below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance positive along the instant race. Distance negative opposite to instant race. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance positive along the instant race. Distance negative opposite to instant race. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. Dispersion, dispersion, dispersion. Splitting white light into 7 colors. Dispersion, dispersion, dispersion. Splitting white light into 7 colors. Dispersion, dispersion, dispersion. Splitting white light into 7 colors. Dispersion, dispersion, dispersion. The band of colors is known as spectrum. The phenomena re-emission of light in all directions with a different intensity is known as scattering of light. Dispersion, refraction of light by the atmosphere is known as atmospheric refraction. Myopia, 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 myopia. Near distance we can see far distance we can see myopia, myopia, myopia. Okay, so after so many days singing, myopia, finally we came to the topic, myopia topic. So today we are going to discuss about human and colorful word. Topic we'll discuss. So human and colorful word topic we'll discuss. Okay. So first we'll discuss about human eye parts and function. Human eye parts and function we'll discuss. Human eye parts and function. Okay. So normally if you are considering here, if I am considering here, okay. So human eye parts and function, human eye and colorful word. So topic is human eye and colorful word, human eye and colorful word. CBSE grade 10 physics. CBSE grade 10 physics. CBSE Grade 10 Physics. Okay. So in this topic, we'll discuss about especially human eye parts. Human eye parts. Okay. So eye diagram. How to draw the eye diagram? We'll discuss about it. How to draw the eye diagram. Okay. So now we can see how to draw the eye diagram. So I'm drawing eye diagram. So you can see here, like this. I'm drawing. So draw the circle, complete circle you draw. First you have to draw the complete circle like this, complete circle. Okay, first we have to draw the complete circle. Then so here you are considering this the cornea, optic nerve, and this the cornea. This portion is cornea. This portion is the cornea. Front layer is the protective layer. So front and protective is the cornea. Okay, so I'm taking the islands here. Islands here. I'm taking the islands here. Islands here. Okay. So from here I'm consider like this. So I'm considering here. Okay, so like this I'm considering. So this the optic nerve I'm considering, optic nerve. And here you can observe, here you can observe, here you can observe. Okay, these are the optic nerves, optic nerves. So I'm considering here the front layer, protective layer of the human eye is called the front layer, protective layer of the human eye is called cornea. The front layer, protective layer of the human eye is called cornea. Okay, so I'm considering here. This is cornea. So front layer, protective layer of the eye is called. Okay, so you can observe. You can observe this is the cornea. I'm considering this is a cornea. Cornea. This is a cornea. Cornea. And here I'm considering this is the iris. 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 And this one is ciliary muscles. These are the ciliary muscles. Ciliary muscles. Ciliary muscles. Ciliary muscles. Okay, so this iris, the ciliary muscles, and this one is the eyelens. Eyelens. Eyelens, and here this medium is called aqueous humor. Aqueous humor. Aqueous humor. So this is the people. This gap is called people. 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 Okay. And here this portion is complete. This portion is so this portion is completely filled with vitreous humor. The front portion, whatever it is filled with completely filled with okay. So here I'm considering here. This portion is completely, this portion is whatever we are taking, this portion completely, this portion is vitreous humor, vitreous humor, vitreous humor, and here is the retina, retina, and this one is optic nerve, optic nerve, optic nerve. Okay. So next you can see, next I'm considering here a blind spot will be there, blind spot. So don't worry about it. After mentioning again, I will explain the parts. Explain the parts. You don't worry about it. So now you are considering here. You can see. You can see. Okay. So this is the cornea. So this cornea is the frontal layer, protective layer of the eye. So here frontal layer, protective layer. So I'm considering here. This is the frontal layer, protective layer of the eye. Most of the refraction takes place at this part. Most of the refraction takes place at this part. So this is the frontal layer, protective layer of the human eye. Protective layer of the human eye. This is the frontal layer, protective layer of the human eye. Most of the refraction takes place at this part. And coming to the see, these are the ciliary muscles. 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 I am concerned these are the ciliary muscles. So you can see, observe here, ciliary muscles. Okay, so these are the ciliary here and here. These are the ciliary muscles. Ciliary muscles. And this is the eye lens. Eye lens I am considering here. Eye lens. Eye lens is a crystalline lens. Eye lens is a crystalline lens, convex lens. And these are the ciliary muscles. This one and this one are ciliary muscles. And this is the iris. And this portion is the iris. This portion is the iris. Okay, iris I am considering. And the next one, this is the pupil. The gap between this one iris, this one also iris. The gap between that is called pupil. That is called pupil. That is called pupil. Okay, pupil I am considering. And this front, this layer completely filled with this entire portion. This entire portion is filled with. Okay, here you can observe this entire portion is filled with jelly type liquid material. This entire portion is filled with jelly type liquid material that is called vitreous humor. Vitreous humor. This entire portion is filled with jelly type liquid material. Jelly type liquid material that is called vitreous humor. Vitreous humor. Vitreous humor. And here retina. So retina is the entire this portion completely filled with jelly type liquid material. Okay, so liquid material, so it gives the sufficient force and pressure to the eye, so to maintain that shape, and retina is a light sensitive screen. Retina is a light sensitive screen. Retina is a light sensitive screen where most of the light rays will meet at this point. Light sensitive screen. So light rays will meet at this point. Light rays will meet at this point. So image will form at this point. Image will form at this point. So what type of image will form? At retina, what type of image will form? At retina, what type of image will form? At retina, what type of image will form? Real and inverted image. Real and inverted image will form. Real and inverted image will form at retina. So that will convert to an electrical signal that will pass to the brain. That will pass to the brain. So through optic nerve, 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 through optic nerve. Real and inverted image will form at retina. Real and inverted image will form at retina. Okay. So here, what are the images forming at retina? Okay. So that image will be converted in the form of signal and reach to the brain through optic nerve, and reach to the brain through optic nerve, optic nerve. Okay, so it will carries the electrical signals to the brain, Okay, so that is a blind spot. There won't be any image will form. That is a dark place. There won't be any image will form. That is a dark place. Okay, so where all the nerves will we are going to the, where all nerves are going to the brain. And here once again, what are the points we discussed? Once again, we'll discuss about it. So cornea is a front layer, protective layer of the eye. Cornea is a front layer, protective layer of the eye, where most of the refraction takes place. And coming to the iris, iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm. Okay, image will be converted in the form of electrical impulse also, electrical signals like that. Okay, electrical signal, electrical impulse, like that. So it will pass to the brain through optic nerve. And here these are the iris. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Which controls the size of the pupil. People will control, see, this is a people. People will control the amount of light entering into the eye. People will control the amount of light entering into the eye. People will control the amount of light entering into the eye lens. So eye lens is a convex lens, crystalline lens. Eye lens is a convex lens, crystalline lens. So whenever light ray falls on it, it will converge the light rays and make it falls at retina, And ciliary muscles will adjust the curvature of the eye lens. Ciliary muscles will adjust the curvature of the eye lens. Ciliary muscles will adjust the curvature of the eye lens. So to see nearby object as well as far by object, ciliary muscles. So I'm taking, these are the ciliary muscles, this portion and this portion. Wherever the, so where if you are taking the balloon here, if you are considering this a balloon, so here ciliary muscles will act like this. So upper portion will be like this, lower portion will be like this. So it is like a convex lens. If it is acting a convex lens, this balloon acting as a convex lens. Okay, so it will hold like this. It will hold upper portion and lower portion. Okay, so it is in the form of convex lens. Whenever the light rays falls on it, it converts the light rays and make it falls at retina. So this balloon, so it's like a convex lens. If you are taking it as a convex lens, okay. So whenever light rays falls on it, on the convex lens, it converts the light rays and make it falls at retina. Is it clear? So I hope that is about clear. Next one, that is about eye lens. Cornea over, pupil will over, iris is completed, and ciliary muscles completed, eye lens is completed. So aqueous humor is a jelly type liquid present between cornea and eye lens. Aqueous humor is a jelly type liquid present between cornea and eye lens. Aqueous humor is a jelly type liquid present between cornea and eye lens. So it provides a sufficient. It provides a blood and nutrition to the central cornea. So once again, vitreous humor is a jelly type liquid material present between eye lens and retina. So this entire portion is filled with jelly type liquid, that is vitreous humor. So between eye lens and retina. So retina is the light sensitive screen. So there real and inverted image will form at retina. Real and inverted image will form at retina. Real and inverted images form. Real and inverted image will form at retina. Real and inverted image is forming at retina. So at retina, real and inverted image will form. That will convert into electrical signals that pass to the brain through optic nerve. So blind spot, as I said, there won't be any image will form. So no light rays will reach to that point. No image will form. No light rays will reach to that point. That is a dark place. So that's why it's blind spot. Optic nerve. These nerves will carry the information. To the brain. Actually, here you can observe brain. So now you can observe here. See, this is a balloon. If you are taking this is a balloon. Okay, so you can see only 2D image. So brain will give the additional information, how much depth it is, how much distance it is, how far it is. So this everything will give. How much depth it is, how much width it is, how much far it is. Everything it will give. Everything will give the brain. Brain will add that additional information. Only we are seeing 2D image. That will form real and inverted image at retina. That will convert to electrical signal and reach to the brain. Brain will give the additional information. Okay, so that how much distance it is, how far it is, how much distant it is, and how much depth it is. Everything it will give. So that we are seeing the 3D image, that we are seeing the 3D image. So this is about human eye parts and function, human eye parts and function, human eye parts and function. So next one we are going to discuss about myopia. So just now from long back onwards, so many days onwards, we are singing song myopia. So finally, what exactly the myopia? So I'll teach with the form of concept to remember in easy way, concept plus and a song. So in the form of songs also I'll discuss. Okay, so if it is useful, if it is helpful, you can utilize it, you can so you can sing this one, you can sing with me. Okay, so those who know that, so myopia song, because many days we are working on it, we are learning on it. Okay, so we are preparing that song, we are listening that song. So now you see. So now time came. So we'll see that song. That song is myopia, 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 myopia. Near distance we can see a far distance. Celebration of myopia. So even balloons are supporting for a myopia song. So for okay, giving crackers in the form of balloon blast. Okay, so that is about myopia, intensity of myopia song, and importance of myopia song. Ready? Myopia, myopia, myopia. This is my first song which I created. So many years onwards I'm singing this song. Ready? Come on. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see a far distance we can see a myopia, myopia, myopia. Near distance we can see a near distance we can see a far distance we can see a far distance we can see a myopia, myopia, myopia. For that correction we are using bro. What bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Myopia, myopia, myopia. Near distance we can see a far distance we can see a myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens. Okay, so like that. So we are discussing about myopia song. So myopia song. Same. I'll teach the same concept. Whatever I discussed, whatever I thought, whatever I given the same concept, I'll discuss in the format of diagrams, in the format of concept. Okay. So a person is there. This is a myopic person. So I'm taking this myopic person. Okay. So I'm considering here. This is a myopic person. He can see near distance. Near distance is 25 centimeter. Far distance is infinity. So infinity I'm taking. Normally near point is nothing but. So I'll tell. So the minimum distance up to which The minimum distance up to which the person can able to see clearly without any strain, without any pain. Okay, the minimum distance up to which, a person can able to see the object without any strain, that is called myopia. That is called, sorry, near point. That is a near point, 25 centimeter. Okay, so that is also known as least distance of distance vision. The minimum distance up to which the person can able to see clearly without any strain is called so least distance of distance vision. So I'm taking here, I'm considering here, if I'm taking the object, if I place certain distance, so we can see comfortably. If you bring very close to us, we can't able to see that. If you're bringing very close to us, so our eyes will get strain and pain. Okay, so that is about that is the reason. Okay, so ciliary muscles can't contract beyond the point. Beyond its required limit. So that is the reason. So we will get strain and pain. So certain distance only we can able to see. That is nothing but 25 certain limit, minimum limit, that is 25 centimeter. So minimum distance only we can see, until 25 only we can see. So below that we can't able to see. Ciliary muscles can't able to contract the eye lens to see the nearby object. So when you are seeing the nearby object, eye lens must be contracted. Okay, so eye lens must be thick, focal length will decrease, then only we can able to see the near distance object. When you are seeing the far distance object, eye lens will be relaxed, focal length increases. That's why we can able to see far distance object. Here the minimum distance, certain limit will be there, certain minimum limit only we can able to see the object, that is 25 centimeter. Within that 25 centimeter we can see the object without any strain, without any pain. That is the reason. So we can able to see. That is also called least distance of distance vision. Least distance of distance vision. That is nothing but near point. The minimum distance up to which a person can able to see clearly without any strain, without any pain. The minimum distance up to which a person can able to see clearly without any strain, without any pain is called near point. Near point is 25 centimeter for normal healthy person. So for far point, you see the maximum distance up to which the person can able to see clearly. Okay, so without any strain or pain. Okay, so that is the reason. That's why it is called maximum point. That is nothing but far point. Far point is infinity. Near point is 25 centimeter. Far point is infinity. Near point is 25 centimeter. Far point is infinity, near point is 25 centimeter. Far point is infinity, near point is 25 centimeter. Is it clear? Yes. Now, so myopia song you can see. Myopia, near distance we can see, far distance we can't see. Myopia. For that correction we are using concave lens. What are the points I'm saying? That is converted in the form of lyrics. Near distance we can see, far distance we can't see. For that correction we are using concave lens to correct the defect of myopia. That's enough. That is only right. That is only song right. Near distance we can see, far distance we can't see. For that correction we are using concave lens. Here also same thing. So the myopic person can see near distance 25 centimeter. He can't see the far point. Infinity he can't see. So the person can able to see near distance, but he can't able to see this distance. Okay, far distance he can't able to see. So how can we correct this effect? First point is we have to take. See, I will say one thing. So he can't see this point. Okay, he can't see this point, but between 25 to infinity, somewhere in between you can see, right? Somewhere in middle you can see. So 25 you can see. So that's enough. Near point you can't see. Near point you can't see. But somewhere between 25 to infinity you can see. Somewhere between 25 to infinity you can see or not? Yes or no? Yes or no? Yes, yes. So that's where in between you can see. So I'm taking this point is far point of myopic person. Far point of myopic person. So for myopic person, the far point is the less than infinity. For myopic person, the far point is for myopic person, the far point is less than infinity. For myopic person, the far point is less than infinity. So I'm taking here. So I'm considering here. I'm taking like this. As I said, if the light rays are coming from far point, you can see, right? So now one more. So light rays are coming from far point, you can see. So for correction of myopia, we are using concave lens. For correction of myopia, we are using concave lens. Yes or no? Okay, so like this, so we can observe. So this is the far point of myopic eye, far point of myopic eye, far point of myopic eye, far point, far point of myopic eye, myopic eye. So this myopic eye. So this is a correction of myopia. Correction of myopia. So this is about correction of myopia. So once again, you can see. Okay, so here you can observe far point of myopic eye. As I said, so the person can able to see near distance. 25 centimeter he can see. I said 25 centimeter he can see, but he can't see the far point. Infinity he can't see. He can see 25 centimeter. Infinity he can't see, but between infinity to 25 centimeter, but infinity to 25 centimeter he can see between this point. Okay, so for myopic person, far point is less than infinity. For myopic person, far point is less than infinity. So less than infinity. So image will form if the light rays are coming from far point. If the light rays are coming from far point, so image will form at retina. If the light rays are coming from far point, okay, so the image will form at retina. So if the light rays are coming from infinity, as I said, infinity can't see, right? Infinity can't see, yes or no? So that's why here you see, so these dotted lines represent, light rays are coming from infinity. These dotted lines represent light rays are coming from infinity. If the light rays are coming from infinity, so image will form in front of the retina. This is the retina, in front of the retina only the image will form. In front of the retina only the image will form. So here you can see what lens we are using. Concave lens. What lens we are using? So here you can see this is a concave lens. We are using here, concave lens. So if you are using concave lens, so it is a diverging. If divergent light rays falls on convex lens, again it will converge and make it falls at retina. So this is a correction of myopia. Correction of myopia. Is it clear or not? Okay, so far point of myopic eye, correction of myopia. Far point of myopic eye, correction of myopia. As I said, same thing in the song itself. In the song also, I said the same thing. What is that? Myopia, 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 myopia. Near distance we can see her. Near distance we can see her. Far distance we can see her. Far distance we can see her. Myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens, concave lens. So here you can see, so you can see the correction of myopia. So for correction of myopia, we are using concave lens. For correction of myopia, we are using concave lens. Here you can see. So my 4 point myopic eye, correction of myopia. So this is about myopia. This is about myopia. Next one, we are going to discuss about hypermetropia. Come on, everybody be ready. Hypermetropia. Hypermetropia means, so we can see hypermetropia, 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 hypermetropia. Far distance, we can see. Far distance, we can see. Near distance, we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using, we are using convex lens, convex lens, convex lens, convex lens, hypermetropia, hypermetropia. Once again, so now I'll sing the song with music. So remember once. Hypermetropia, 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 hypermetropia. For a distance, we can see. Near distance, we can see. Hypermetropia, hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens, hypermetropia, hypermetropia, convex lens, convex lens. Okay, so like that, as I said, convex lens we will use for correction of hypermetropia. What is hypermetropia? Hypermetropia is nothing but we can see far distance, we can't see near distance. We can see far distance, we can't see near distance. For that correction, we are using convex lens. Hypermetropia is nothing but, so far distance we can see, so near distance we can't see. For that correction we are using convex lens. So convex lens. Okay. So now you can see. I'm taking this person. So this person can able to see far distance. So here I'm taking, so this is the 25 centimeter, this is infinity. So he can see this point, but he can't see this point. But one thing I said, between infinity and 25 centimeter, infinity and 25 centimeter, somewhere else he can see. Between that he can see, right? So in between that he can see, that is the near point of hypermetropic eye. Near point of hypermetropic eye. Near point of hypermetropic eye. So as I said, he can't see the near point. We can see far point, but between infinity and 25 centimeter, 25 centimeter, he can see in middle. He can see. Yes or no? In middle he can see. So now we'll draw the diagram. If you are taking the diagram like this, so I'm taking the diagram. So what lens we are using to correct this defect? What lens will use? Convex lens. What lens we are using? Convex lens. Yes or no? Convex lens will draw. Convex lens. Okay, so now you can check the diagram. If you want, you can check the diagram. Okay, so check the diagram. So this is about near point of hypermetropic eye. Near point of hypermetropic eye. So and this one is the this diagram is the hypermetropic eye. Hypermetropic eye. Hypermetropic eye. Hypermetropic eye. This is the diagram of hypermetropic eye. This is the diagram of hypermetropic eye. This is the near point of hypermetropic eye. Near point of of hypermetropic eye. This is the near point of hypermetropic eye. This is the hypermetropic eye. So this is hypermetropic eye. Here, so I'm considering here. This is the correction of hypermetropic eye. Correction of hypermetropic eye. Correction of hypermetropic eye. Correction of hypermetropic eye. Is it clear or not? Is it clear or not? Is it clear or not? Check once, check once, check once, check once. Here, when the light rays are coming from, if the light rays are coming, actually I said, so he can see he can see for infinity point. As I said, infinity point, far point he can see, but he can't see the near point. He can't see the 25 centimeter. Far point he can see, infinity he can see, but he can't see 25 centimeter. Between infinity and 25 centimeter he can see. Between infinity and 25 centimeter he can see. So that middle point is near point of hypermetropic eye. That near point is near point of hypermetropic eye. So this point is near point of hypermetropic eye. I am considering here, if the light rays are coming from this point, so image will form at retina. So if the light rays are coming from 25 centimeter, as I said, so he can't see the 25 centimeter. If the light rays are coming from 25 centimeter, image will form at beyond retina. Image will form at beyond retina. So if you are taking, so this is a near point. I'm taking. I'm considering N. So from N, if the light rays are coming, from this point, if the light rays are coming from this point, if the light rays are coming from the N, so by using convex lens, we can correct this defect by using convex lens. We can correct this defect. Light rays are coming from near point. If the light rays are coming from near point, by using convex lens, light rays will be converging meet at retina. So if you are extending this dotted lens will meet at N dash. N dash. Yes or no? Yes or no? So same thing I say. So same thing. Whatever song I created, that only. So hypermetropia, 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 hypermetropia. Far a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using, convex lenser, convex lenser, convex lenser, convex lenser, hypermetropia. Understood? So like that, hypermetropia. For the correction of hypermetropia, we are using convex lens. That's enough. So near point of hypermetropic eye. So hypermetropic eye, correction of hypermetropic eye, correction of hypermetropic eye, correction of hypermetropic eye, correction of hypermetropic eye. As I hope it is very clear to you all. So next one, we are going to the one more I am considering. So presbyopia is nothing but the person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. For the correction of, for the correction of presbyopia, we are using bifocal lens. Upper portion is concave lens, lower portion is convex lens. Convex lens. So convex lens. Once again you can see. So I'm telling presbyopia. Presbyopia is nothing but the person can't able to see near distance as well as far distance. Presbyopia is nothing but the person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. For the correction of presbyopia, we are using bifocal lens. Upper portion is concave lens, lower portion is convex lens. Upper portion is concave lens, lower portion is convex lens. This is about presbyopia. Next one, cataract. A milky and cloudy will form on eye lens. So a milky and cloudy will form. Okay. So milky and cloudy type will form on the eye lens. So by laser surgery we can remove that. That is about cataract. Astigmatism. One more defect is astigmatism. Astigmatism means, so we can't able to identify the horizontal lines and vertical lines properly. Horizontal and vertical lines we can't able to identify. So for the by using suitable cylindrical lens, we can correct the defect. By using suitable cylindrical lens, we can correct the defect of astigmatism. Understood? So this is about the defects. Next one. If the light ray passes, see, next coming. So whatever I am going to discuss. See. So what are the points I'm going to discuss, that you will sing in the format of song, in the format of song. Okay, ready? Say with me, learn with me, sing sing with me, say with me, learn with me, sing with me. Dispersion, dispersion, dispersion. Splitting a white light into 7 colors is known as dispersion. Dispersion. Say with me, learn with me, sing with me. Dispersion, 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 dispersion. Splitting a white light into 7 colors is known as dispersion. Dispersion. Refraction of light takes place by the atmosphere is known as atmospheric refraction. Atmospheric refraction. Atmospheric refraction. The band of colors is known as spectrum. The band of colors is known as spectrum. Dispersion. Dispersion. Say with me, learn with me, sing with me. Dispersion. Dispersion. The phenomena of re-emission of light in all directions with a different intensity is known as scattering of light. Scattering of light. The phenomena of re-emission of light in all directions with a different intensity is known as scattering of light. Scattering of light. Scattering of light. Scattering of light. Come on. Say with me, learn with me, sing with me. Dispersion. Dispersion. Say with me, learn with me, sing with me. Dispersion. Dispersion. Yes, so whatever I am discussed, whatever I explained the topics, whatever I discussed all the points, so interaction class, so around 11 o'clock or 11 o'clock it will be there. Okay, so come and join to the class. So maximum, still few more points are there. I hope it will take half an hour. Okay, so come and join at the time, 11 o'clock, around 11. Interactive class will be there. You can interact with me. Okay, done. So now I'm considering one more. So whatever I'm discussing the points, okay, whatever I sang the points like a song, so those points I'm discussing, those points I am explaining now. Okay, whatever points I'm explaining, those only I sang in the sung in the form of song. Here you can see dispersion, right? So when the light ray passing through the prism, so I'm taking the prism like this. Okay. So if the light ray incidenting on it, so along this one, if the light ray is passing, so the splitting of white light must be below this one, because so it's split into 7 colors. 1, 2, 3, 4, 5, 6, and 7. Those 7 colors. Okay. So 7 colors. It form like a 7 colors. So 1, 2, 3, 4, 5, 6, 7. So this all colors will form like a band on the screen. Like this. So this band is called. So all light colors will form like a band like this. So 1, 2, 3, 4, 5, 6, 7. 7 colors. Those 7 colors like a band on the screen, like a band. Okay, so it will move towards the base. So the light ray will move towards like this base. So you can take down. So it is not appearing that much. So that's why I'm again drawing like this. So you can see all those 7 colors will form like a band. Okay, so like that I'm considering violet, indigo. The order is violet, indigo, blue, green, yellow, orange, red. Vibjia. Okay, those seven colors will form like a band. So as I said, dispersion, splitting a white light into seven colors is known as dispersion. So light, whenever light passes through the prism, split into seven colors, seven constant colors. Those are violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. So these are the seven colors. Those seven colors will form like a band on the screen. Okay. So the band of colors is known as spectrum. So those seven colors will form like a band, right? So those seven colors will form like a band on the screen. That is called spectrum. That is called spectrum. Splitting of white light into seven colors is known as splitting of white light into seven colors is known as dispersion. The splitting of white light into seven colors is known as dispersion. So those seven colors will form like a band on the screen is called spectrum. Okay, spectrum. Okay, those seven colors, that is nothing but violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. So violet divide the most, where red divide the least. Okay, least. Violet divide the most, red divide the least. Okay, so based on the refractive index, based on the wavelength, so based on the refractive index, based on the wavelength, so it depends. The deviation depends. Deviation, according to that, deviation takes place. So it bends. So here I'm considering here whatever I'm considering here. So violet, indigo, blue, green, yellow, orange, red. So the band of colors is known as the band of colors is known as spectrum. The band of colors is known as spectrum. Splitting white light into seven colors is known as dispersion, right? So that's so when you place the when the light ray passes through the prism, split into seven colors. So if you take that, actually Newton want to, so Newton did this activity, that is experiment when light ray passing through that, when light ray passing through. Is this really live? Yes, I am live only. So you are seeing me only. So you are seeing me only. I am Shiva sir. From my channel is Student the Brand. Okay, this is live only. Okay. So next one. Here I am considering. So Newton sent the light through prism, split into seven colors. It split into seven colors. Again you want to split into the colors. Split the colors again. So he placed normal mode. So he placed like this. So he placed the same as it is, however it is. But those seven colors, so further no dispersion takes place, as it is seven colors only came out. So seven colors only formed. So that is the reason. So what he did, so he placed the inverted prism. Like this. So we'll draw the diagram for it. That is recombination of spectrum of white light. Recombination of spectrum white light. Recombination of spectrum of white light. Recombination of spectrum of white light. Yes, NCRT 10th NCRT physics only. So CBSE grade 10 physics. Yes, NCRT textbook only. You can check once. So NCRT textbook itself. Okay. So I'm taking this one. Next one I'm considering one more. Okay. So if the light ray is passing, so actually Newton want to split further light rays. So he placed the normal prism, so normal position, but he didn't get. So what he did, he placed the inverted prism. Inverted prism like this. So you can observe. I am taking like this. So light ray is passing. Like this. Light ray is incidenting on it. So those colors actually here we can take. So below that one we can consider like this. Okay, so this is the prism 1, prism 1, this is prism 2, prism 1, prism 2. So actually light rays are coming, light rays are forming. So these are the light rays. So these are the light rays I'm taking here. These are the light rays, these are the light rays. Like this I'm considering. So this is the white light, white light, white light, white light, white light, white light. So this is also white light on the screen. White light, white light. So here lower portion is violet, upper portion is red. Lower portion is violet, upper portion is red. Okay. So when the light ray passing through the prism, when light ray is passing through the prism, okay. So it's split into seven colors, seven colors. Those seven colors. Again, those seven colors will form on another prism, inverted prism, inverted prism, inverted prism. Okay. So those seven colors will combine. Those colors, seven colors will combine and form as a white light. White light, as you can see, outcome as a white light. Outcome as a white light. Outcome as a white light. Also, this is called recombination of spectrum of white light. Recombination of spectrum of white light. Recombination of spectrum of white light. Spectrum of white light. So recombination of spectrum of white light. Here, as I said, Newton disc, you know, right? Newton disc. So place or paint on the disc all seven colors and rotate it and rotate it. So how it will be? It will be appears as a white color. So here, so all the seven colors will mix and form, will mix and come out as a white light. So incident light is white light. After incidenting, so again it passes through the second prism. Second prism will combine those seven colors will come out as a white light. So will come out as a white light. Okay, so that is about recombination of spectrum of white light. Recombination of spectrum of white light. Recombination of spectrum of white light. Okay, so next one we are going to the one more. Raindrop, 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 raindrop. Okay, so now you are considering here. One more I'm taking, one more I'm considering. So one more I'm considering here. That is so rainbow formation by water droplet. Rainbow formation by water droplet. Rainbow formation by water droplet. Okay, so I'm taking the water droplet like this. So light ray is incidenting on it. White light. Those colors will split into seven colors. Violet and red. Okay. So next you can observe here. You can observe when white light passes through the water droplet, raindrop. This is about raindrop. This is about raindrop. Raindrop. Okay, raindrop. 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 Rainbow formation by raindrop. Okay. So when light ray passes on it, The light ray passes split into 7 colors. Is split into 7 colors. Those 7 colors will reflect internally. So we'll get outlet as a rainbow. It go outlet as a rainbow. We'll get outlet as a rainbow. Here we can see one point. So what is the phenomena involved in the formation of rainbow? What is the phenomena? What is the phenomena involved in the formation of rainbow? So the phenomena involved in the formation of rainbow, 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 refraction, dispersion, internal reflection. The phenomena involved in the formation of rainbow. The phenomena involved in the formation of rainbow. The phenomena of the phenomena involved the phenomena involved the phenomena involved in the formation of rainbow, refraction, dispersion, internal reflection, refraction, dispersion, internal reflection, internal reflection. The formation of rainbow, the phenomena involved in the formation of rainbow, refraction, dispersion, internal reflection. That is about phenomena involved in the formation of rainbow, refraction, refraction, refraction. Second one is dispersion, 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 and internal reflection, internal, 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 internal reflection. Because so actually it is a transparent object, transparent object. Okay, so whatever the light ray is passing, some of the light may be observed, some of the light will be refracted, and so like that. So the some amount of light only it will reflect. That is the reason internal reflection. In our textbook also will use internal reflection. So what is the phenomenon in the formation of rainbow? What is that? Refraction, dispersion, internal reflection. When white light passes through the raindrop, this is a raindrop. Actually, each and every tiny water droplet, each and every tiny water droplet, each and every tiny water droplet act as a prism. Each and every tiny water droplet act as a prism. When white light passes through it, split into 7 colors. The phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. I hope it is very clear to you all. So next one, we are going to the one more. Okay, so we'll see now. So that is about so already refraction by rainbow. So next one we are going to the refraction, atmospheric refraction. So I already sung the song. So you see, whatever I sang the song starting, those songs one by one I am explaining. Those lyrics, those lines one by one I am explaining. So this is the This is the next one. Refraction by the atmosphere. So refraction by the atmosphere is called atmospheric refraction. Refraction by the atmosphere is called atmospheric refraction. Best example, I'm standing here. So I'm standing here. So this is the balloon you can take. This is the file. I'm standing this side. Your friend is standing another side. So if you view through it, when we view through it, what happens? When we view through it, what happens? So the person who are saying we are standing another side, it appears flickering, it appears blinking, it appears flickering, it appears blinking, because of the refraction. Hot air. So this is a fire, right? Hot air. Best example, hot air. Hot air act as a rarer medium. Cold air act as a denser medium. When light ray passes from hot air to cold air, so it refraction of light takes place. So if it is keep on refraction, so that's why the image. So the image another side appears flickering, it appears blinking, it appears flickering, it appears blinking. Yes, and it appears blinking, flickering. So as you see the image how it is blinking like that. Okay, so like that it will be there. That is about refraction. Atmosphere refraction by the atmosphere is called atmospheric refraction. This is what I'm saying, that is small scale. So that is in small scale. If you're taking a big scale, so light ray is coming from the star. From large distance. What happens if the light rays are coming? So I'm standing here. If I'm standing here, so light rays are coming from far distance. So like this, if you are taking, so when it is keep on light rays are coming far distance, what happens? So take it as a star. So it keep on changes the refraction. The light ray direction changes. So actually the star is here, so it appears here. So this is apparent position. This is the actual position of the star. This is the apparent position of the star. Apparent position of the star. Okay. So actual position, star actual position, star apparent position. Because when keep on refraction takes place, when keep on refraction takes place, what happens? So the image appears flickering and blinking. So here in atmosphere, light rays is coming from far distance. It keep on changing the direction. That's why. So the image appears here. The image of the star appears here. Actual position is here only. But it appears here above its actual position. The star appears little bit above the actual position because of atmospheric refraction. Even sun appears. Advanced sunrise and delay sunset. Advanced sunrise and delay sunset also. Because of atmospheric refraction. Advanced sunrise and delay sunset also. 2 minutes advance, 2 minutes delay. So because of atmospheric refraction, you am considering here. So here if I'm considering here, okay. So I'm taking like this. So you can observe. So earth I'm taking, earth I'm considering, okay. So this is the earth. So atmosphere, this is atmosphere. So here this is the origin. So sun is here. Sun is here. Light rays are coming from here. If the light rays are coming, so because of the atmosphere, So if the light ray is coming from here, whenever the light rays enter into atmosphere, so here if you are standing here, okay, so it bends, so then it appears here above the origin. Above the origin it appears here. So this actual position of the sun. Actual position of the sun. This is the apparent position of the sun. Okay, so this is the actual position. If the light rays are coming from that point, if the light rays are coming from that point, so because of the atmosphere it will bend. Because of the atmosphere it will bend. So at this atmosphere place, so the light ray will bend. Because of that reason, here apparent position. This is the actual position of the sun. So 2 minutes, 2 minutes advance sunrise and 2 minutes delayed sunset. 2 minutes advance sunrise and 2 minutes delayed sunset. Okay, so because of the atmospheric refraction, the sun appears here. Okay, 2 minutes advance and 2 minutes delay. 2 minutes advance, 2 minutes delay. Okay, so I hope it is very clear. I hope it is very clear. So this is about atmospheric refraction. Because of atmospheric refraction, and sometimes sky appears blue color. Sometimes sky appears blue color. Sometimes sky appears blue color, and sky appears blue color, and ocean appears blue color, and reddish during evening time and morning time. Sky appears reddish color. So due to scattering of light, due to scattering of light, due to scattering of light. Okay, so the wavelength of the light incident on it, so I'm considering here. So what is wavelength? Wavelength I'll explain. So I'm taking here. So this is about, so if you are drawing like this, if you are drawing like this, so the distance between two consecutive crust and two consecutive trough, the distance between two consecutive crust or two consecutive trough is called wavelength. The distance between two consecutive crust or two consecutive trough, the distance between two consecutive crust or two consecutive trough is called wavelength. If the particle incident on the, if the particle is incidenting on the, so if the light ray incidenting on the particle, if the light ray is incidenting on the particle, okay, so this particle size, if it is comparable to the wavelength of the light, if the particle size is comparable to the wavelength of the light, so this particle will absorb the light, and re-emit in all directions, with a different intensity, in all directions with a different intensity. So whatever the light incidenting on it, this particle size is comparable to the wavelength of this light, wavelength of the light incidenting on it, wavelength of the light incidenting on it, wavelength of the light incidenting on it. Then the particle re-emits light in different directions with a different intensity, with the different directions with a different intensity, with the different directions with a different intensity. Okay, with the, in all directions, we can say all directions, in all directions with a different intensity, in all directions with a different intensity is called scattering of light. So this also I sung in the song. So last line, so the phenomena of re-emission of light in all directions with a different intensity is known as scattering of light, scattering of light, scattering of light, scattering of light. So I am considering here, whenever light ray falls on it, so that particle will scatter the light in all directions with a different intensity. In all directions with a different intensity is called scattering of light, is called scattering of light, is called scattering of light. Okay, so related to color, sky appears blue color, sky appears blue color, sky appears blue color. So sun during evening and morning it appears reddish color, sometimes it appears white color, sometimes it appears white color, and blue color of the sky, blue color of the sky, and deep sea also it appears blue color. This all related to colors, this all related to colors. If it is related to colors, that is scattering of light, that is scattering of light, that is scattering of light. Next one, Tyndall effect. Tyndall effect means, Tyndall effect is nothing but, So the path of the light becomes visible. The path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through the colloidal solution. So because of the colloidal solution, the light will scatter. Light will scatter in all directions with a different intensity. In all directions with a different intensity. In all directions with a different intensity is called scattering of light. It's called so light will scatter in all directions with a different intensity. So the path of the light becomes visible when it is passing through the colloidal solution. The path of the light becomes visible when it is passing through the colloidal solution. That is known as Tyndall effect. When you open the door in the morning time, immediately the sunrise will come. So there you can observe the dust particles are flying. So during rainy time also near to the bulb, the moisture, the air, so water moisture will fly. So we can able to see that moisture, okay, dust particles flying. And you can see in the when you are moving in the on the road. So in the middle of the road, if the many trees are there, so in the middle of the tree, so this narrow beam of light falls in that. So dust particles are flying, dust particles fly. So dust particles will fly, then that one. So it is known as Tyndall effect. So I hope it is very clear. So we discussed all the points. Okay. So almost everything is completed. Scattering of light, Tyndall effect, and so everything we discussed related to human and colorful word. So that's enough the about today topics. So we'll discuss about this one. Thank you so much. We'll see you in the next class. So with the next different topic. Thank you for joining.